Hello guys, welcome back to another COMC video. Today we review another question here, and as always, let's first start by reading the question. So this is from the COMC 2008 contest. This is the 8th question of part A, and as always, let's first start by reading the question. So, determine the sum of all integer values of the parameter r, for which the equation x to the power 3 minus rx plus y plus 11 is going to be equal to 0. So to start off by doing this question, let's move all the terms that contain r to one side and all the terms that contain everything else into the other side. So this is going to be turned into, let's say, x to the power 3 plus 11 is going to be equal to rx minus r. Here we can look at rx minus r here, and we can take out the r. So r times x minus 1 is going to be equal to x to the power 3 plus 11. Now let's isolate the r here, and let's divide the other side by x minus 1. Now, obviously, this equation is pretty useless, to be honest. So we're going to turn this into something else. We're going to do this. So instead of x to the power 3, x to the power 3, not x to the power 2, x to the power 3 minus, plus 11, let's do x to the power 3 minus 1, and on the bottom, x minus 1 as well. But obviously, where did that 12 go, right? We just took away 12. So that's why you need to add it back later in the equation. So this is still the same equation I just separated. I just turned the 11 into a negative 1 and a 12. From here, we can then look at x to the power 3 minus 1 and x minus 1. We can expand x to the power 3 minus 1 and then divide it by x minus 1 to receive x squared plus x plus 1 plus 12 divided by x minus 1. So not expand, sorry, x to the power 3 minus 1, just do some long division with x minus 1, and this is what you receive. I can actually do a long division right now. Let's do that. X to the power 3 minus 1, let's do some long division with variables. I'll show you guys how to do it. So with x minus 1 here, let's see. What do we need here to get x to the power 3? Well, obviously x squared. And x squared times x is going to be x to the power 3. X squared times a negative 1 is going to be minus x squared, negative x squared. Similarly to regular long division, you should do the same thing, but with variables now. So I'll complete the rest of it for you guys to see. Yeah, so this means that x to the power 3 minus 1 divided by x minus 1 is just going to be equal to x squared plus x plus 1. That's where we got this from. And after that, we add the 12 divided by x minus 1 from before. Now we can see here that x cannot be equal to 1. Because then this would be not valid, right? 12 divided by 0, that's not defined. So we can see here that x cannot be equal to 1. Now, going back to our equation here, we need to see that r has to be an integer. And so, we need 12 divided by x minus 1 to also be an integer. Now, this is because x squared plus x plus 1 is already going to be an integer, as we know x is an integer as well. So we just need x minus 1 here to be a divisor of 12. So what values of x make it so that x minus 1 is going to be a divisor of 12? Well, we can see here that x has to be equal to these numbers: 13, 7, 5, 4, 3, and 2. So these are the numbers so that x minus 1 will be a divisor of 12. So now, let's just plug in what this would be with r. So for x equals 3, we have r is going to be equal to 184. If we have x equals 7, we can see that r is going to be equal to 59. And then if x is going to be equal to 5, we get 34. If x is going to be equal to 4, we get 25. If x is equal to 3, we get 19. And if x is equal to 2, we also get 19. Now we need to determine the sum of all integer values of r. So we cannot double count 19 here because these two are literally the same. So we can't double count them. So we just have to count. We have to add 19 once. And so this means that the answer to your question has to be the sum of these values, which would be 184 plus 59 plus 34 plus 25 plus 19, which is going to be equal to 321. So the answer to this problem is 321. Thank you guys for listening. If you have any other way to solve this problem, please let me know down below in the comments, and thank you guys for listening. Bye!